Okay, here's the video you've been waiting for. Many of you really enjoyed my FPV night flying video that I posted about 3 months ago and wanted me to do a how-to video to show how I set up the LED lights and the strobe. So here it is. Now this is a very comprehensive video and I will be covering many things, including how a multi-switch works, how to use a multi-switch to use just one channel to turn on up to 7 devices on your plane, how to use a Y connector so you don't even have to give up a single channel which may already be in use, how to hack a panic alarm to make a cool noisemaker on your aircraft, how to install and solder LED lights and the various pros and cons of different LED strips, using relays to increase the amount of current the multi-switch can handle so it can power higher current devices, how to use a multimeter to measure current draw from LEDs and other accessories, and a whole lot more. So first, let's get to the very heart of this LED setup, which is this little device. Now this is a multi-remote switch. This is the key to operating more than one item with the same channel on your radio. So it comes by itself with the switch itself, and it also comes with 7 of these power leads which plug into these outputs right here. Now setting this up is extremely simple. I'm going to show you how it's done real quick. Okay, first of all, I've got my transmitter and I've already bound it to this El Cheapo receiver. I've got a battery pack, a puffed one. This one never goes in the air anymore because it's all puffed. So we're just going to plug the battery in to, we'll stick it on auxiliary 1, I guess. Okay, it powers up. Now you take this switch. Okay, here's the deal. This wire goes right to your receiver, and the power from your receiver, which comes from your receiver battery, is what powers the circuitry in here, okay? This lead here, they give you JST plugs to solder onto your battery source, okay? So these, you're going to be soldering onto some type of battery source, whether it's a 6 volt or 7 volt or 12 volt or whatever. Okay, so this wire, I'm going to plug right into the gear channel, and you can see it light up, okay? And it kind of goes through an initialization process. Now when you first get it, you're supposed to calibrate it, and normally what it does is it blinks until you flick this back and forth multiple times, and then it's supposed to stop blinking. Okay, this one's already calibrated though. Now the next thing you can do is plug it right into your power source. Now obviously I don't have the correct leads here. I've got a 12 volt battery, a 3-cell puffer pack here, and I can't plug it in, so I made an adapter real quick. Plug this in, and then plug this in. Okay, now my adapter that I made happens to have a switch on it, but you can ignore that because you don't really need a switch at all. So I shut it off. Now there's no power flowing. But when I turn it back on, you can tell by this red LED that it now has 12 volts supplied to it. Now one thing to understand is that the receiver controls which one of these output ports puts out power, but the power does not come from your receiver battery. The power gets piped in from whatever power source you connect to this JST plug here. So I can control the multi-switch with my gear button, okay? So now I'm going to plug in, I made beforehand a whole bunch of LED light strips and all kinds of stuff. So I'm going to plug those in now and we'll be right back. Okay, so now we're all powered on. We've got the receiver on, powered by this battery. The receiver is controlling the multi-switch, and the multi-switch has power, which is coming from a 12 volt battery. Okay, so now anytime we turn on one of these 7 outputs, it's going to put 12 volts out to these power leads that come with the multi-switch. So as you can see, I got 7 things plugged in. I've got some LED lights here, I've got another LED light here, same size one here. I've got a bigger LED light here, and then I've got an even smaller one. This is the smallest LED light, is this yellow one. And then I've got this little custom device, which is that noisemaker. I only had 6 LED lighting devices, and so I was trying to find something else that I could use to power off of 12 volts, just to show you guys what you could do with this device. So anything that runs off of whatever voltage that you put into the switch, you can power. I thought about sticking this whoopee cushion on my plane, but it's kind of heavy and I don't think people would hear it from the air. However, this little device is a panic alarm. Now normally you take this when you jog, but I'm going to modify it. God, that's loud. I'm going to take this apart and modify it, and I'm going to stick this on my plane. So I'll use this as a device also to show you that you can power just about anything. This takes 12 volts, so it runs off 12 volts. It'll run off our 3-cell LiPo, no problem. I'll just unsolder those and unsolder these and we'll be good to go. I'll have it all wired up. There we go. Speaker and electronics. I'll mount the electronics inside my plane and mount the speaker on the side somewhere probably. And there's the finished wiring. So right here we've got 12 volts which comes in, and then this is just right to the speaker. I put a plug on the speaker just so I can connect it anywhere I want in the plane. And I've got this little custom device which is that noisemaker that I was showing you how to make real quick. And so this is going to be the noisemaker. All these things run on 12 volts. Okay, and obviously when you buy your equipment you got to make sure it runs on 12 volts because some of the LEDs run on less volts. So you can use a 6-volt battery, or a 7-volt battery, like a 2-cell battery or something like that, and then just power LED, 7-volt LEDs or whatever. You can also, instead of running 12 volts out, I can have 12 volts here and then run some step down voltage circuitry or whatever, or use a UBEC, but we're not going to get into all that here. We're just running straight 12 volts and 12 volt equipment. Now I've got the switch set to setting 5. Setting 1, 2, 3, and 4, when you power them up, they cause voltage to come out of these, but only for a second or two, and then they shut right off. And they're for specific uses. Some people like to use rocket launches and stuff with these. So that's why it gives 12 volts or whatever voltage to it, and then it'll power off right away. That's 1 through 4. 5 through 9, once you turn the power on, it stays on until it cycles through all of them, and then they'll shut off, depending on which mode. And the modes are all explained in the instruction sheets, which you get with the multi-switch. Okay, now that we're up and running, one of the most important things you have to know about how to operate this switch is it operates by a quick flip. Okay, now to give you an example, if I just flick it like that really slow and then shut it off, nothing happens. Nothing turns on. So in order to operate the multi-switch, you have to give what I call a quick flip. Just like that. You see how I did that quick? See how it turns it on? Up and back, just quickly like that. Up and back. That's one cycle. Ah! There's that annoying alarm. That's loud. Okay, then one more flick of the switch and they all go off. So just remember that. That's a safety feature they built into it, I think, so that you don't accidentally set something off when it's in the air, like a bottle rocket or something. I don't know. I guess that's why they have that. But again, if you accidentally hit it, no big deal. Just press it back after more than a couple seconds and nothing comes on. So nothing comes on that way. Okay. So once again, here we go. You can turn them on pretty quickly in succession. And then one more flick, and they all shut off. I'll run through it again, showing you what happens at the multi-switch itself. Okay, so they're all off right now. See how the switches light up one at a time, the green lights? One at a time, until number 7. That loud, annoying one, which is going to be really cool. Now, as you're adjusting whichever setting you're going to program this for, I'm going to move it to setting number 1, and the green LEDs will light up according to how it's going to fire. So as you can see, it starts from the outside and it works itself in. It goes through 2 cycles showing you exactly what it's going to do. Okay, and then you're ready to make it work. Okay, if I go to setting number 2, same thing. It's going to cycle through. This time it starts in the center and works its way out. So you can, without having to move all these switches around, you can alter the sequence of firing or lighting, whatever you want to call it, just by moving this little switch. Now, as I was saying before, settings 1 through 4 are a quick fire setting, okay? And 5 through 9 are, once they're on, they stay on until you shut them off. Now I'm going to give you an example of a quick fire setting. We're going to put it on 1. Okay, so it goes this way, that way, that way, that way, that. That tells you the sequence they're going to come on. Now by quick fire, this is what I mean. Now normally you saw just a minute ago how you flick this switch and it stays on. Well, watch what happens now. See, it only stays on for a second. Oh, the far one lit. Okay, now the next one, this one's going to go next. See, it comes on and then goes off. Okay, the next one, this yellow one's going to go. See how it goes on and then shuts off? Okay, now the blue one's going to go on. See, it goes on and shuts. So it stays on for about a second or so. That one, and then the final one. Okay, so they all went off. Now one more quick flick of the switch, and it goes back to 0 again. Now I'll show you an example of how you might have your lights set up on your plane. Let's say you've got this one on a wing, this one on the other wing, and then you've got this light on, say, a wingtip, and this one on a wingtip, and let's say you have this one in the front of your plane. Okay, so basically your plane looks just like that, kind of. So what I have set here is I've got it set on setting number 8. Here we go. The first flip turns the main wing lights on. Next flip turns both of these on. And then the next flip won't power anything because I have nothing powered in there. Watch when I flick it. Okay, it sends power to these two center ones, but nothing comes out. Okay, then the fourth flip turns on the center light. So that's just an example of how you can have these things set up. Now the switch is rated to handle up to 500 milliamps of current on each one of these outputs. So I strongly advise you, before you start plugging things into here, that you test them on a multimeter to determine the current draw. And if you don't know how to do that, I'll show you really quick. First thing you need is a multimeter. Okay, you plug your red lead in to make sure you're measuring for current. You can see it says 10 amps. This one will measure up to 10 amps. Okay, then I'm going to go ahead and turn it to 10 amps. You turn it to the highest setting. Okay, here's how you test current flow for a given item. This goes for anything really that's battery powered. So I got my LEDs plugged in. Whoa, what was that? We'll get back to that later. So we got a 12 volt power source, okay, 3-cell battery. Don't get confused by all the wiring. This is simply powered by 12 volts, by a 12 volt LiPo. There's nothing else in the circuits. Now this here is a special wire that I made up to test for current for these devices. All I did was I snipped the black wire and then I put 2 alligator connectors in between. So I'm going to undo those, so now there's no more current flowing. Now we use the 2 leads from the multimeter to complete the circuit. So the current's going to now flow through the multimeter to the LED lights. Now the LED lights come back on because the multimeter is completing that circuit through the black wire. And it shows us what our current draw is. Right now it's showing 310 milliamps, 320 milliamps. Now we're just going to leave that plugged in and we're going to test some other devices really quick. Okay, so we're going to unplug this one. Now let's plug in. How about this little green LED? Let's plug this one in. Okay, and this one's only pulling 70 milliamps. Okay, 70. There's the blue one. This one's pulling 60 milliamps approximately. This one's pulling 280 milliamps. Okay. Okay, here's the noisemaker thing. I had to put an adapter on the end of this wire just to make it work. So let's go ahead and plug this in. Make sure we got black to black. You won't be able to hear me for a second, but you'll be able to see. Okay, so up to 130 milliamps, which is a little higher than I expected from this thing. This thing actually pulls quite a bit of current. Okay, this is the strobe light that I had in my video that you can see blinking away. And it's pretty heavy. I cannibalized this out of one of those, I think it's out of one of those road flasher things or something like that. It was out of something. I got it from my brother, so I don't know. But let's plug this in. So this is that strobe light. You can see it blinking away. It looks like the current draw is about 220 milliamps approximately. So the current draw on that strobe is also under 500 milliamps. So that's why I was able to use this strobe light. So if you try to exceed the maximum current load on any one of these outputs and you get something over 500 milliamps, what happens, this thing will short out, okay? And you'll get what I got here. This is bad number 1 and this one is bad number 2. Both of these I fried very quickly. I was trying to power something which needed more current than 500 milliamps. It was one of these, but I won't get into that right now. Anyway, so make sure all the equipment that you have hooked up to your working switch is 500 milliamps or less. If you want to power something that requires more than 500 milliamps, you can use a relay. A relay, and these are examples, are just simply electronic switches. That's all they are. Okay, this relay does the exact same thing electronically that this manual switch does by me going like this and like this. Okay, what a relay does is it'll take a small amount of current, and this one is at 12 volt. You see how it says 12 volts DC? So this thing is rated at 1 amps. Okay, we'll get to what that means in just a second. But this relay, if you hook it up to one of these 12 volt outputs, very simple, just wire it up. Okay, this here is a coil. Okay, when 12 volts, a minimal 12 volt power source at about, I don't know, maybe 60 milliamps, maybe 50 milliamps or so from this, okay, just a small amount of current is applied to that coil by just, attaching your power to those 2 pins. What happens is that mechanically inside it switches this switch over and it closes that circuit. Okay, so that allows you to use this small amount of 12 volt current as long as you've got another power source plugged in to these other connections here. Okay, it allows this small amount of current to engage this large amount of current, and when this powerful current goes through that relay, it doesn't come close to this multi-switch. Okay, it just pipes it right through. It pipes it through as if you're hitting a switch like this. Okay, so think of it as just like a switch like this. It's just a switch that's powered, instead of by a finger, it's powered by 12 volts, and it flips that switch, and it will carry up to 1 amp. Okay, so you're not limited to 500 milliamps. You can get 1 whole amp of current going through here. If you need something with even more power, go with the bigger relay. This one's rated at 10 amp. I don't know what the hell you want to power on your plane that's 10 amps. These 1 amp relays are plenty enough to power, say for example, a solar igniter. Okay, I installed my multi-switch in my Skywalker so that it sits in this wing compartment right here. I've also got 2 relays. I've got 1 amp relays there. We'll talk about those later. Okay, I have my multi-switch set up on setting number 5, and I'll power this up here so you can see what it does. I'll turn on the Dragon Link, and then I'm going to turn on my plane. This controls my RC electronics. So when I turn that on, watch the green lights. 2, 3, 4, 5, 6, 7. So I have my multi-switch set up to where every time I hit the button, it turns all those on from the first one all the way to the last one in succession. This first output right here turns on my headlight. The second 12 volt output goes through the fuselage, through that rat's nest in there. It goes through the fuselage and it goes to these, what they call corn cob LEDs. Okay, number 3 and number 4 are both these leads right here. And these plug in directly to each wing. One goes into one side and one goes into the other side. So that red JST plug changes to black and blue there, the wires that came with the LED strip. And the LED strip carries all along the bottom, and then it jumps over to the top, to the end right here, and then it carries over to the very tip of the wing right here. Now, I have mine hooked up to where when I turn the radio on and turn the receiver on, there's still no power to this thing. And you can tell there's no power because that light doesn't come on yet. I wired the power. I'm not going to get into the wiring. Now that you know how to wire it, basically the power wires, which come from this side, they go down and they tap into my battery. They actually, I soldered them in right here, right before the current sensor. That way, any current that's getting pulled through that whole system will also register on my OSD. So that's one trick I did. Make sure when you wire this in, if you have an OSD and you want to see how much current overall your motor's pulling plus your LED strips, make sure you wire it in such a way that your current sensor picks up the current. Okay, so what happens is when I plug this in, see how the power comes on now? I just plug that in and now the power comes on. So what I can do is I can show you what it does. When I flick the switch, see how that turns on? And you can see one LED is lit up. Okay, flick it again and my tail lights come on. That's the second one. And then the next one will power one of these. That's to one of these outputs. Flick it again, and the fourth one is to the other one. Okay, now the number 5 and number 6, listen. Did you hear that trip? Listen, I'll cycle through them again. Right there and right there. That was the sound of those relays kicking. Those are those electronic switches right there. They kicked off one in turn. One went off first and then the second one. Those are actually hot right now. And what those do is those pipe down to here, to the side of my fuselage, so I can get 12 volts out of the side of my fuselage. Now a quick word about the LED strips that I used. I picked up 4 Turnigy strips. And on the Hobby King site where I got them, this one's green and this one's white. And then they had blue and red. But one of the things I noticed was that the green and white strips said that they were waterproof. And when I got them, you can see there's like a waterproof like coating on them. So these definitely look like they're waterproof. The red and blue ones did not have any coating on. And those are the ones ultimately that I installed on one wing and then on the other. So these are the ones that had no coating. I think they were slightly cheaper, but I wasn't worried about price, I was worried about weight. These coated ones that are waterproof are twice as heavy as these that don't have waterproofing. And to me that was a big factor because of how much they weigh. Now I'll start with the installation on the wing. It's really straightforward. I used a whole entire strip. Okay. What I did is I started on the tip, and I put one segment on the tip. There's one segment of 3 LEDs. Okay, and I unstuck the tape and then stuck it on there. And then I took 2 pieces of wire, and those are actually kind of a little bit corroded and probably could be replaced. But then I soldered them to the next piece. And the next piece has 5 segments. Okay, and I just kind of, the whole idea was I wanted to be able to see that wingtip coming in. I didn't care about underneath when I was coming in for a landing. I wanted to be able to see a lot of color out there. And that's why I put that one on the wing tip out there like that. Okay, and then I ran some more wire, just soldered it on there, just ran some short wire, and then this is whatever's left. I actually started over here at this end. I stuck that down, and then I ran it all the way out as far as it would go, and it just happened to end up right close to there. So that's one whole strip of LED lights. Okay, now soldering these is extremely easy. I feel kind of bad because I put off this project for a long time because I didn't want to get into soldering. But you can actually cut these strips right here on these lines. Every 3 segments, you can actually snip those just with scissors. And then there's contacts on there. You can see the 2 copper contacts on each side. And you just solder wire directly to those. All you have to do is get your piece of scrap wire, put a little bit of flux on it. The flux is important. And then just get some solder on the tip of your soldering gun and then touch it to it and it just solders right on. It was actually really, really easy. It was very easy to do once I got the hang of it. I used tape, like around these corners. I would tape one piece off with a piece of masking tape to hold it down. And then I would just touch the solder to the wire with the flux and it just sucks right on there and it solders really nicely. And that female JST plug, when I put my wing on, I have 2 of them, one for each side of the wing. They just plug directly into these 12-volt outputs, which are fed by this multi-switch. Okay, this is channel 5, which is that switch on my transmitter. And normally, I used to just control the OSD display. This wire goes to my Hornet OSD, and it controls the screen that I'm actually looking through while I'm flying. So I can cycle through these modes one at a time and it takes me to different screens. And that's what that wire's for. But when I hooked up my bomb drop, which some of you guys might be familiar with through my other videos, I wanted to put this servo in here. And here's the servo wire that controls it, but I didn't have an extra channel. So I just piped the wires off of that channel 5, and when I plug this in, just like that, now I control not only my OSD display screen, but also my bomb drop servo. Okay, and what this means is I can change my OSD screen without actually dropping the football, just by flicking it really quickly. I can cycle through all 4 or 5 of my screens by going like this. And I flick it so fast that the football doesn't drop. But then when I get onto a screen that I like, I just fly around, do whatever. That way I can see all the information that I want. I can change it as much as I want. When I really want to drop the football, I just go like that. Just hold it over and the servo, of course, actuates. And the little football drops. When I installed my multi-switch, basically I had to unplug the bomb drop and plug in. This comes from my multi-receiver switch. This comes from up here. This controls that multi-switch. So now I'm plugging that into channel 5. So now that's plugged in. But doing it this way, I can have either the lights or the bomb drop. However, I use this little Y cable here, plug this in. Now I have both of them plugged in. They come to a Y and they splice in right there. So now I can change my OSD display I can cycle through my lights, and I can also drop a Nerf football whenever I want, just by using this one switch. Now I'll show you how to do that in just a second. I'm going to hook the wing up, I'm going to hook everything on, and I'll show you exactly how that works. Alright, so this is how everything looks right before it gets locked down. Got all kinds of wires going everywhere, but it all makes sense once you understand what it is. Okay, we're all powered up, ready to go. Everything's on, system's all online. Now, I'm going to flip through the lights here. Turned on my headlight, turned on my tail light. Now that turned on my left wing LEDs. One more flick of the switch, turns on my right hand LEDs. So now all my LEDs are on, but as you can see, the football's still there because I'm flicking the switch really quickly. Now the next two modes, those were my circuits, which are on the right hand side and the port side over here. And those, there's nothing hooked up to them, so nothing lights up. And then the 7th circuit, there's nothing there either, because that's going to be my sound, probably that alarm device that I'm going to put on. One more flick of the switch and they all go off. So I can fly around like this, turning my lights on and off, just like that. Cycle through them, just like that, and then they go off. And then if I ever want to drop the football, just hold it, and it falls off. Now one thing to mention here is that if you hold that switch too long, it won't make the lights go on. You see how that works? See how the lights are not coming on? Because you have to do a quick flick, like that. That makes them go on. 7 and then off. That's in case you accidentally flip the switch in flight and you don't want something igniting or turning on. So if you accidentally flip a switch, like, oh, whoa, no big deal, just shut it back off again and nothing happens. Now, of course, my bomb drop will still actuate. But in order to get things to turn on, you do a quick flick. And then off again. Okay?